Hello and welcome to this video on dependent events. So we've already had a look at independent events, which is where one thing doesn't have any impact on the other thing, so we can multiply these two things together. Now dependent events is when one has an impact on the other. So let's have a look at this first question then. So let's get it up. So Yvonne has 10 tulips in a bag. 7 of the tulips grow into red tulips and 3 of the tulips grow into yellow tulips. Yvonne takes 2 random tulips from the, 2 bulbs from the bag and then she plants the bulbs. Complete the probability tree diagram. Now, the reason these are dependent is because when she's taken the first one out, she's not putting it back in. Okay, so she's not replacing it. So this is a way when we look at things where we're not replacing them. In fact, let's just get into it and I think you'll see what I mean in a little bit. So we've got our tree diagram. So we've got here, 2 chances are we're either going to pick red or we're going to pick yellow. And then once you've picked one, you're going to pick a second one. And again, the outcomes are red or yellow. And then red and yellow. Brilliant. So what we're looking at here is what is the probability of picking red on your first pick. Now there are 7 red bulbs in here out of 10. So the first one here is going to be 7 out of 10. Brilliant. So what's the probability then of picking 7? Well, that's going to be, there's 3 in here which are yellow, so that's going to be 3 out of 10. Now, the thing that we need to be really careful of is on this second pick. So we need to write on here, this is first pick, and this one here is second pick. Brilliant. So on that first pick, we've taken a red out. Let's imagine on that first pick we've taken a red out. So if you've taken one red out, how many reds are left in there? Well, if there was 7 in there originally, and then you've taken a red out, then there's going to be 6 reds in there out of. Well, how many are in there in total now? Well, again, if you've taken one out, and there was 10 in there in total, there's now only going to be 9 in total. Okay? Now again, if I've picked a red out, how many yellows are left in there? Well, if I've picked a red out, the same amount of yellows are going to be in there. So, for yellows, it's going to be 3 out of. However, you've taken a red out, so the total has changed. So the total has changed to 9. So let's just try and be really clear on that. If I've taken, on my first pick, a red out, then there's only going to be 6 reds left in there, and there's going to be a total of 9 left in there. If you take a red out on your first pick, then there's only going to be, there's going to be 3 yellows in there. However, there's only going to be 9 in total left in there. So let's have a look now if we pick a yellow on our first pick. So if I take a yellow on my first pick, how many reds are left in there? Well, there were 7 reds in there originally, and if I've taken out a yellow, there are still 7 reds in there. However, the total has changed because you've taken a yellow out. So if I've taken out, there were 10 in there, I've taken 1 yellow out, which means that there's now 9 in there in total. Now, let's think about if I'm going this way. If I've taken a yellow out, how many yellows are in there? Well, there was 3. I've taken 1 out, so that means there's now only 2 left in there out of the total, which is 9. So that's my probability tree diagram complete. Now, that's a little bit different from what we've seen before. It's because I've actually kept one of the counters. All right, so that there is part A done. So you're getting 2 marks for that, okay? So she plants the bulbs, work out the probability that at least one of the bulbs will grow into a yellow tulip. So, the thing we need to think about here are which ones turn into a yellow tulip. So, the probability at least one. Now, that's really important. What I'm going to suggest, first of all, before we do anything, is we work out all of these probabilities. Okay? So, what is the probability of picking red and then red? Well, remember that we times across. So we times across our tree. So it's going to be 7 over 10 times by 6 over 10. So we can do that on our calculator. So 7 over 10 times by 6 over 9. So the probability of picking red and then red is going to be equal to, now I've actually cancelled it down. I'm going to not cancel this down. I'm going to say that's equal to 42 out of 90. Okay, you can cancel that down. And it would cancel down to 7 over 15, but I'm not going to cancel that down. I'm just going to keep it like that. All right, so that's the probability of picking red and then red. What's the probability of then picking red and then yellow? Well, the probability of picking red and then yellow is equal to 7 out of 10 times by 3 out of 9. So 7 times by 3 is 21. 10 times by 9 is still 90. Brilliant. Okay, what's the probability then of picking yellow and then red? Well, that's probability of yellow and then red. Well, yellow's 3 out of 10 times by red, which is 7 out of 9. So 3 times by 7 again is equal to 21. And then 10 times by 9 is equal to 90. Brilliant. And then what's the probability of picking yellow and then yellow? Well, yellow is going to be 3 times by 2, which is 6, over 10 times 9, which is equal to 90. So how can I check that all of these are right? Well, there's a really simple way to check that these are right, so that we can add them all together. So 42 out of 90 plus 21 out of 90 plus 21 out of 90 plus 6 out of 90, and this should be equal to 1, which is 90 out of 90, which it is 90 out of 90. Brilliant. So that one's perfect. So we've done our tree, we've got our probabilities. Okay, the next thing to do is to answer this second part of the question. So work out the probability that at least one of the bulbs will grow into a yellow tulip. Well, if we want the probability at least one is a yellow tulip, well, which ones have got yellow tulips? So we've got red and red, so no, we haven't got a yellow tulip in there. Red and yellow, yes. Yellow and red, yes. And yellow and yellow. So what the options are, the probability of picking red and then yellow, and then plus the probability of picking yellow and then red, plus the probability of picking yellow and then yellow. So these are all the different options of picking a yellow tulip. Now, the reason that we're adding these together is because they are mutually exclusive events. So that means that you can't get a red and yellow and then a yellow and red from here. You can only either get red and yellow, or you can get yellow and red, okay? So we can add these together. So the probability of getting red and then yellow is equal to 21 over 90, plus the probability of getting yellow and red is equal to 21 over 90, plus the probability of getting yellow and yellow, which is equal to 6 over 90. We add all those together. 21 plus 21 plus 6 is equal to 48 out of 90. Okay, so with that one there, the probability of getting at least one yellow, okay, is equal to 48 out of 90. Brilliant. Super. So there's a lot going on there. First of all, we've got to consider the fact that these are changing. We'll talk about that a little bit later. And then we've got to work out these by multiplying across the table, because they are, although they're dependent events, the probability of both of these happening means we multiply. And then we find the probability out of just the yellows by all these three here. So I add these ones together. Super. All right, so let's have a look now. Let's just check those answers first of all. Brilliant, 48 out of 90, and then we've got all of those. That's perfect. Super. So let's have a look at this next question then. So the probability that it will rain on a day, in fact, I'll make it big for you so you can see it. The probability that it will rain on a day in June is 0.2. When it rains, the probability that my tennis match is cancelled is 0.7. When it does not rain, the probability my tennis match is cancelled is equal to 9.5. Complete the probability tree diagram for this information. Now, the first thing to note here is remember that all of these branches on here do need to sum to 1. So 7 over 10 plus 3 over 10 is equal to 10 over 10. Perfect. 6 over 9 plus 3 over 9 is equal to 9 over 9, which is 1. So all of these sets of branches do sum to 1. That's important. Okay, so let's have a look at this diagram then. So we've got two events here, and that's the weather first of all, and then it's also whether he's playing tennis or not. Okay, so with the weather, it's either if it rains or it does not rain. So it's either when it rains or it does not rain. Okay, and then with tennis, it's either his match is cancelled, so it's either cancelled or the match is not cancelled. And then same here again. So it's going to be equal to cancelled or it's not cancelled. Okay. Now remember that these are two independent events, so it's about making sure we understand what this actually means. So let's look at the first one here. So it says the probability that it will rain on a day in June is equal to 0.2. So the probability that it rains on a day in June is equal to 0.2. Super. Now because we know these sum to 1, these two pair of branches, that we know that this must be equal to 0.8. Now we're going on to the dependent part, because the first part says when it rains, the probability the tennis match is cancelled is equal to 0.7. So when it rains, the probability that it's cancelled is equal to 0.7. Super. That means the probability that it's not cancelled is equal to 0.3. Okay? So the next part says when it does not rain, the probability that the match is not cancelled is equal to 0.95. So when it does not rain, the probability that it's not cancelled is equal to 0.95, which means the probability that it cancelled is equal to 0.5. Super. So, work out the probability that on a day in June, it does not rain and my tennis match is cancelled. So what I will do is, you don't need to do this extra little part. You're going to get all the marks, 3 marks of this part. But I want to think about all these different probabilities. So what's the probability that it rains and that it's cancelled? The probability here that it rains and is not cancelled. Rains and not cancelled. The probability that it does not rain and is cancelled. So not rain and cancelled, and the probability that it does not rain and that it is not cancelled. Let's have a look at all of those. Now remember, when we're going across, we multiply, okay? So if we want the probability that it rains and it's cancelled, it's going to be equal to 0.2 times by 0.7. So 0.2 times by 0.7 is equal to 0.14. So super, move that over a little bit. The probability that it rains and it's not cancelled is equal to 0.2 times by 0.3. 0.2 times by 0.3, which is equal to 0.06. The probability that it does not rain and it's cancelled is equal to 0.8 times by 0.05, which in this case is equal to 0.04. The last one, the probability that it does not rain and is not cancelled, is equal to 0.8 times by 0.95. Super. So that's equal to 0.76. Now remember, you can check these answers, and the way that we check them is by adding them all together, and they should sum to 1. So 0.14 plus 0.06 plus 0.04 plus 0.76 is equal to 1. Super, there it is. 1, perfect. So, okay, so let's have a little look at this second part now. Now the second part says, work out the probability that on a day in June, it does not rain and my tennis match is cancelled. So, with this one here, we're looking at, we've already done the probability, so we're just looking along our tree. So we want the probability that it does not rain and that it is cancelled in this case. So I'm going to write cancelled. Brilliant. Okay, so what's the probability it does not rain and is cancelled? Well, we know the probability it does not rain is equal to 0.8 times by the probability it's cancelled, which is equal to 0.05. Now, we've already done this. I'm just showing the examiner again. So 0.8 times by 0.05, which is equal to the 0.04, which we've already got there anyway. Brilliant. So with that one there, it's the probability that it does not rain and is cancelled is equal to 0.04. Now we've only actually got one outcome there, okay, that we're looking for. So let's have a look now at let's just check that's right first of all. Yeah, super, 0.04, brilliant, and all those answers are right. So let's have a look at this one now. I'm going to pop this up because I want you to pause and have a little go at this one yourself. So pause now and have a little go at that one yourself. Okay, so let's have a look at this one together. So a darts team is going to play a match on Saturday and on Sunday. The probability the team win on Saturday is equal to 0.45. If they win on Saturday, the probability they win on Sunday is equal to 0.67. If they do not win on Saturday, the probability they will win on Sunday is equal to 0.3. Complete the probability tree diagram. Okay, so we've got two different events here, and the two different events are the two different days are equal to Saturday and Sunday. Brilliant. And the two different outcomes are either that they win or they lose. And again, win or lose, win and lose. Now, the reason it's dependent is because depending on what happens on Saturday, we see what's happening on Sunday. Okay, so the probability will change. So let's have a look at Saturday first of all. So it says the probability the team will win on Saturday is equal to 0.45, which means that the probability they lose is going to be 1 minus that, which is equal to 0.55. Super. Then we go on to the next stage. So if it says if they win on Saturday, so they win on Saturday, the probability they win on Sunday, so here, is equal to 0.67. Super. So if they win on Saturday, then it's 0.7, so it's going to be 1 minus this for if they lose, which is going to be 1 minus 0.67, which is equal to 0.33. Super. So it then says, if they do not win on Saturday, so if they lose, the probability they win on Sunday is equal to 0.35, which makes sense because if they've lost, they might feel down and they might not, the chance isn't as good. So if they win on Sunday, what's the probability they lose on Sunday? Well, it's going to be, again, 1 minus 0.35, which is equal to 0.65. So we've got these now. So what we need to do is we need to work out. Okay, so let's get all these probabilities down. So we're going to look at it first of all, the probability they win and they win. Then the probability they win and then lose. Then the probability they lose and then win. And then the probability they lose and then lose. So remember, we multiply across. So the probability that they win and they win is equal to 0.45 times by 0.67, which is equal to 0.3015. Super. Move that across a bit so you can see it. Then the probability that they win and then lose is equal to 0.45 times by 0.33, which is equal to 0.1485. Super. Then the probability that they lose and then win, which is equal to 0.55 times by 0.35, which is equal to 0.1925. And the last one, lose and then lose, 0.55 times 0.65 is equal to 0.3575. Now remember, we add all these together, we check whether it's going to be equal to 1, so it's going to be 0.3015 plus 0.1485 plus 0.1925 plus 0.3575 equals 1. Super. Brilliant. So we know that these are right. So let's go on to the next part of this question. So the next part says, find the probability that the team will win exactly one of the two matches. Now, when it says exactly one of the two matches, it means it's only winning one of the two matches, obviously. So it can't be this top one, because here they win 2 matches, win and then win. Here they do win exactly one match, because they win and then lose. And here they do win exactly one match, because they lose and then win. And here they just lose both, so I'm not including that one. So if we want the probability of getting winning exactly one match, probability of winning exactly one match there is equal to the probability of winning then losing plus the probability of losing then winning, which we know. So this is equal to, I'll do it underneath actually, 0.1485 plus 0.1925. So it's the probability they win and then lose and then win. So let's have a look at that. So 0.1485 plus 0.1925, which is equal to 0.341. 0.341. Super. Brilliant. So, hopefully you got that question right. So let's have a look now. We're going to move on to some trickier questions. Okay, so we're going to look at some of these ones here. Now, there are only, I'll make it big for you so you can see it. Now, do make sure you're getting these down in your notes, because remember, the only way to learn maths is to do it. So there are only 5 black counters and 4 red counters and 2 white counters in a bag. Charlie takes 2 random counters from the bag. Work out the probability that Charlie takes at least 1 red counter. Now, this one here is tricky, okay? Now, first of all, we want to work out with this one all of the different outcomes for picking exactly 1 red counter, because that's what it says. So in fact, it says at least 1 red counter. That means it includes red and red. So the different outcomes are going to be that he picks, well, let's start with red and red first of all. So red and then red, because that's at least 1. Okay. Then we want red and then black. Brilliant. So let's have everything with the first one red. And then we've got red and then white. So the first one's red. But we've also got, if the second one was red, so it's going to be black and then red, and then black and then white. Okay? So this here is all the different combinations of picking at least 1 red. Okay? Red and red, at least 1 red. Red and black, at least 1 red. Red and white, at least 1 red. Black and red, and then I put black and white there, sorry. That should be white and red, sorry, shouldn't it? White and red, which is at least 1 red. Super. So, the next thing we need to think about is the probability of these happening. Now, we've got here, now that I've written it like this, we don't use a tree diagram for this one. We just need to think about all of the outcomes, which is what this makes this harder. So, we've got our first pick, and then we've got our second pick. Okay? Our first pick and our second pick. So, how many are in total in here? Well, the amount that are in total in here are equal to 5 plus 4 plus 2, so it's going to be equal to 11, okay? So the probability that he picks a red counter on his first pick is going to be 4 out of 11, okay? Because there's 4 counters out of the 11 in total in this one, okay? Now, if he's picked a red counter on his first pick, what's the probability of picking a red counter on his second pick? Well, the probability of picking a red counter on his second pick is going to be equal to, if he's already taken 1 out, there was 4 in there, he's taken 1 out, there's now only going to be 3 in there, out of a total, well, there was 11 in there, he's taken 1 red out, so that means it's out of 10, okay? And remember that we're looking at the probability here of picking red and then red. In fact, I'll make that a little bit smaller, just so we can fit it all in. So it's going to be 4 out of 11 times by 3 out of 10. So the next one we're looking at is the probability of picking red on the first one and then picking black on the second one. Okay, so the probability of picking red on the first one we already know is 4 out of 11. Now, how many blacks are in there? Well, there's 5 black counters in there. I haven't picked one of them out yet, so it's going to be 5. But the total has changed because I've taken a red out. So it was 11, I've taken 1 red out, which means that it's now going to be over 10. Brilliant. So the next one is picking red and then white. Well, we know the probability of picking a red one first is going to be 4 out of 11. And then for picking a white on the second pick, well, how many whites are in there? Well, it's going to be 2 out of the total, remember, is reduced to 10. Okay. Then we want the probability of picking black and then red. Well, what's the probability of picking black on my first pick? Well, there's 5 black counters in there out of a total of 11. So it's going to be 5 out of 11 times by picking a red. Well, I haven't picked a red out this time. So there's still 4 red counters in there. But the total, again, is changed because I've picked 1 black out. So the total is going to be over 10. and then picking a white and then red. So the white counters are going to be 2 white counters in there out of 11, times by picking a red, which is going to be 4 out of 10. Now, with this one here, so this is the key one, I'd say, because it's understanding if I've taken one red out, 4 out of 11, okay, then there's only 3 left in there out of 10, okay, and you've got to do all of these different outcomes. That's the tricky part. So then what we do is to work out the probability of getting all of these, we need to multiply them all together and then add them all together, because these are all of the different outcomes. So it's going to be 4 over 3 times by 11 over 10, which is going to be 12 over 110. 4 over 5 times by 11 over 10 is going to be equal to 20 out of 110. 4 over 11 times by 2 out of 10 is equal to 8 out of 110. 4 over 11 times by 4 over 10 is equal to 20 out of 111. Last one, 2 over 11 times by 4 over 10 is equal to 8 out of 1,110. Super. So we've worked out all of the different probabilities of picking one red. Now, if we want the probability of all of these together, then we add all of these together. So it's going to be 12 out of 110 plus 20 out of 110 plus 8 out of 110 plus 20 out of 110 plus 8 out of 110. So 12 plus 20 plus 8 plus 20 plus 8 is equal to 68 out of 110. That is tricky, that question, okay? It's tricky because you've first of all got to work out all of the different outcomes of picking one red. You've then got to really think about the probability of getting each of these here. And then we've got to work them out. So let's just check the answers. But it's 4 marks. Okay, usually that's towards the back end of the higher paper. Okay, so 60 out of 110. Super, brilliant. So let's have a look at this next question. Okay, so this next question is the last question, and it's definitely the trickiest, okay? So I'll pause now, make sure you do have a little look at this one. Do make sure you're getting it down. Remember, the only way to learn maths is to do it. So this one here says, there are 8 counters in a bag. There is a number on each counter. Fiona takes a random 3 counters from the bag and adds the numbers on the 3 counters to get her total. Work out the probability that it is an odd number. Okay, so this is 4 marks, so it's very similar kind of level to the last one, but again, this is tricky because she's taking 3 out now. Now, the first thing that we need to think about is which numbers can I add together to make an odd number? Now, if you're making an odd number, you need to have an odd amount of odd numbers in our addition. Now, what do I mean by that? So let's just have a little look at this. If I do 2 plus 4, that's going to be equal to 8, which is an even. Okay, so that's going to be even plus even plus even. So we know that an even plus an even is an even is an even. Now, if I do even plus odd, so let's go 2 plus 1, this is equal to 5, which is an odd number. And that's because we've got one odd number in our list, okay? In our addition, sorry. Now, if I did even plus odd, the problem with that is I'm adding 2 odd numbers in there, so that's an even amount of additions. So if I did 2 plus 1, this is equal to 4, which is even, which is not what I want. Now, so the trick is I want to have an odd amount of odd numbers to make an addition, to make an odd, okay? Very tricky to explain that. So let's talk about now. Let's have a look at all of the different outcomes for getting an odd. So you can check some of these if you want. It's probably worth checking to make sure that you understand it. So to get an odd number, I need to add an odd plus an even, okay? The other option is that I write and add an even plus an odd plus an even. Okay, notice there's only one odd in there. There's only one odd in here. Then the other option is that I add an even plus an odd. Okay, that'll give me an odd number. Now the other one, which I need to think about, is odd plus odd plus odd. Because there's an odd amount of odds. We can check that if we want. 1 plus 1 plus 1 is equal to 3, which is going to be equal to an odd number. So yes, that one works as well. Now, these are all the different outcomes for getting an odd number. Now, the next thing I need to think about is the amount of numbers which I have in here. So I'm going to think about my first pick. That's the important one. Okay, so for my first pick, okay, I'm looking at the probability of it either being odd or the probability of it being even. So the probability of it being odd, well, how many odd numbers are there? Well, it's going to be 1 and 1, which is 2, and then 5, 5 and 5. So there's actually 1, 1, 5, 5, 5. There's going to be 5 numbers which are odd out of 8. So the probability of picking an odd number on my first pick is equal to 5 out of 8. Super. The probability of picking an even number is going to be 2, 4 and 4, which is equal to 3 out of 8, which makes sense because they add together to make 1. Super. So, this is for my first pick. Now, I do need to know this because when I pick one, I'm not replacing it, and that's really important. So, what's the probability of picking an odd number on my first pick? Well, the probability of picking an odd number on my first pick is, we've already worked this out, is equal to 5 out of 8. We know that. What's the probability of picking an even number on my first pick? 5 out of 8. This one here is going to be equal to the 3 out of 8, which we've already worked out. First pick even, 3 out of 8. First pick odd is 5 out of 8. Okay, now, the next question is, if I've picked an odd number, what's then the probability that my next number is going to be even? Okay, so let's just think about this. If I was to, let's write these numbers down. Let me move up a little bit so you can see. So I've got 1, 2, 4, 4, 5, 5, and 5. So if I picked an odd number here, look at this. If I picked an odd number, okay, what's the probability of me picking an even number? Well, if I've picked an odd number, there are still 3 even numbers left. However, because I've picked an odd number, there's a total of 1, 2, 3, 4, 5, 6, 7 left. So actually, if I've picked an odd number, the probability of picking an even number is equal to 7, is equal to, there's still 3 even numbers in there, but it's out of 7. Okay, so now if I've picked an odd and even, and then I'm picking another even, so if I pick one odd and one even, what's the probability of me picking an even number? Well, if I've picked an even number on my second pick, it means that there's only 2 even numbers left. Okay, so this is going to be equal to plus 2 out of, and again, if I've picked an odd and even number, there's only 6 left there. You can see 1, 4, 4, 5, 5, 5. So that's equal to 2 out of 6. Okay, so these should be times because they are independent there. Okay, so that's our first section. Again, I know this is tricky, I know this is tough, but do take your time, make sure you're trying to take it in. So if I've picked an even number on my first pick, so let's say I've picked an even number, what's the probability of me picking an odd number? Well, if I've picked an even number, that means I've still got 1, 2, 3, 4, 5 left over there. So times by 5 out of 7, which is left over. And then if I've picked an even and an odd, how many evens are left in there? Well, if I've picked an even, so there was 3 evens in there at first. Okay, 1, 2, 3. But I've picked one of them out, and now I'm picking a second even. So the probability of picking a second even is equal to 2 out of 6. This is tough, okay? This is tough. I know it's tricky. So the next one is picking even, even, odd. So I've already got the probability of picking even, which is 3 out of 8. I've put times in here. All of these should be times. Well, I suppose it is picking even, so I'll just keep them with that actually. So picking even, even. So picking, if I've picked an even on my first go here, what's the probability of me picking an even on my second go? Well, the probability of picking an even, there's only 2 here, so times by 2 out of the total, which is 7. So if I've picked two evens, what's the probability of me picking an odd? Well, it's going to be 1, 2, 3, 4, 5. There's still 5 in there. But it's out of 1, 2, 3, 4, 5, 6. 5 out of 6. Brilliant. Okay. So there we've looked at those first three. And the last one is probably the easiest one to think about. So if I picked what's the probability of picking an odd on my first pick? Well, it's going to be 1, 2, 3, 4, 5 out of the 8 times by, if I've picked an odd number, how many odd ones are left? It's going to be 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 4 out of 7, times by, if I've picked two odds, then what's the probability of me picking one more odd? Well, there's only 1, 2, 3 left over, so times by 3 out of the 1, 2, 3, 4, 5, 6. So we've got all of those different combinations, okay? And it is tricky to understand that, okay? So do take your time and make sure you actually get it. You've got to think about all the different combinations of odd and even, okay? And remember why we had addition in there. We had addition in there because we're actually adding these together. But when we're working out the probabilities of each of these, we times them together, don't we? Okay? So here we've got, let's work out the probability of getting odd, even, even. That's going to be 5 out of 8, 5 over 8, times by 3 over 7, times by 2 over 6, which is equal to 5 over 56. Let's look at this next one. So 3 over 8 times by 5 over 7 times by 2 over 6, which is equal to, same, 5 over 56. Now this makes sense. There's actually a little trick we can think about here, because if you notice, these are just all the same multiplications, but just in different orders. So what we could have done is worked out one of these and times it by 3. I'm just going to keep going for now. We know this one's going to be equal to 5 out of 56 as well. But the other one we need to think about is when it's odd, odd, and odd, which is going to be equal to 5 out of 8 times by 4 out of 7 times by 3 out of 6, which is equal to 5 out of 28. Now, if we want the probability of all of these things happening, then we need to add them all together. So it's going to be 5 out of 28 plus 5 over 56 times by 3, because there's 3 of them, okay? Or you could just add them all together. So just add all of these, and that's equal to the probability of, at least one odd. Oh, so the total is odd. The probability that a total is odd is equal to 25 out of 56. And that's simplified down there. So it's because we thought about all of these different outcomes. That is tricky, okay? There's lots going on there. So let's just make sure we've got this right. 25 out of 56, absolutely super. So let's have a go at some of these ourselves. I'm going to put some of these up. So do take your time with these because they are tricky. I've got quite a few questions here. So first of all, pause now and have a little go at these. There's 2 sheets to have a look at. So pause now and have a little go at that. First one. Okay, so then pause now and have a little go at that second sheet. You've got some of those trickier questions down here for 13, 14 and 15. Okay, so I'm going to pop the answers up. So mark those in green. There's your first set of answers for the first worksheet. So mark those in green. If you've got those right, well done. Okay, so then here's your second lot. Mark those in green for me, please. Okay, so thank you for watching that video on dependent events, which is probability. Do make sure you're having a go at these questions, because remember, the only way to learn maths is to do it, and have a wonderful day.